How's everybody doing? We're still winding up from the other talk. Rock on. All right, so I'm Dustin. This is about getting you more radio frequency curious, using some tools that are open source, feeding data to those tools, and getting out of the command line just a little bit so that we can have a database of things. So, general disclaimer, this is, I'm not a lawyer, I'm not your lawyer, nobody's lawyer. Get a lawyer if you have a lawyer. Find one. This is really just for educational purposes. We are passive scanning, we're passive receiving, we're passively dealing, and we are just receiving. We are not sending or transmitting any data when we look through these pieces. The last line is just for comedy. This is about me. My mother makes me put this up because she made me go to school. It took me 5 years to get out of engineering school, so just stick with it. You can do it too. And so I've been a bunch of years, ex-SOTA R&D person, currently a cybersecurity engineer, worldwide war drive winner, 2020 something, it's up there, right? 2022, 2025. I found a really good quad this year that cleaned it up. But I've been a builder of all these monitor things, the war driving stuff, the Bluetooth stuff. So I've been using Kismet wireless to do this heavy lift. And so I want to get you folks into understanding how you can too see all the things around you. So I love this quote. It's really not from Walt Whitman, even though Ted Lasso wants us to think it is. I wasn't able to find anything that told us it was really from Walt Whitman. But sometimes tools have been around so long that they can sometimes be the villain, and I think sometimes you hear tools get kind of crapped on a little bit, and I just want to make sure that we keep going with being curious. So Kismet Wireless. Kismet Wireless, most people use it for Bluetooth, Wi-Fi scanning. It's totally a workhorse for that. Use it 90% for grabbing PCAPs, grabbing that data, being able to ingest it. I use it for all my war driving. It does some BTLE, the Bluetooth low energy stuff, so it'll capture those beacons. Those are randomized, right? So not really too user detectable, but they're there, and some are not, right? So if you have a flipper, right, your flipper, your Bluetooth device is not randomized, so just be aware of that if you leave it on. But what about the ISM bands? What about software-defined radio stuff? How do we find things that are out there, this industrial, scientific, medical band, where they're free license and they have to just deal with whatever they may see in the world, right? How do we track those? How can we see those? And, you know, normally we would grab software-defined radio tool and then we would see these waterfalls. It'd be like, well, this is a radio station because it was just easier, but how would I figure that out? What would be in that thing? If I tuned to 915 or 315 or 433, what would I see? I would see these things, but I wouldn't know what they are. And there are other tools that are out there that'll do it for you. You could use SDR Sharp. You can use some tools with some plugins, and it'll do some decoding for you. I forgot the tool off the top of my head that'll actually give us some details. But what can you find? So I mentioned 315. There's motion and security and TPMS sensors, tire pressure monitoring sensors or system, whatever it is, right? Those are in your tires. You have 4 of them. They're all unique. I'm going to just leave that out there. Just think about that when you drive around. They're all unique, all 4 of them. So it gets a little tricky. Weather stations like to beacon a whole bunch of information, temperature, weather, things like that, all in the clear text, as well as some remote sensors for your doors, like your alarm system. So how could we see them? Because there isn't any encryption. It's very open. Oh, sorry, 915 as well, security sensors, other ultra utility sensors. We'll see some of those, as well as water, gas, and electric. I don't have electric by me in that band, but I do have water and gas. So I'll have some screenshots. So as I said, you know, we go through spectrum analysis and you'll see what's in the air around you, and that software-defined radio is trying to scan all the way across. It's trying to find things. How do you capture? How do you sit there? We use it, right, to capture any of the noise that might be out there. Maybe you've got a hum. Maybe you've got something. If you're amateur radio person, you might fire one up to kind of see, is the neighbor's utility pole blowing up or something impacting your radio frequency? You can kind of look for it, but I want to see things, right? I want to know what's out there. I want to be able to see what those devices are. And so we get to these tools for SDRs and how do we feed them into data. So RTL SDR has a built-in tool, command line interface, right? I'm getting a little bit ahead of myself, but again, you know, you can get a $40 tool and you can see all these things. You can do AM, FM. You can, if you're close enough to an airport, you can hear some airport traffic, right? The NOAA just does a beacon weather. And then if you get really nosy and you have an active amateur radio club near you, you can listen to their repeaters or simplex, right? You can kind of do things. Maybe you record them and push them to the internet and share them in like Broadcastify or something. So I mentioned it before, you know, an inexpensive SDR, 30, 40 bucks from RTL SDR blog, or the new Elect seems to be a little bit more of a favorite for folks. Small PC, you can use a Raspberry Pi, and then I'm a bigger fan of a little bit more power, like the N150, the N300 CPUs from Intel. But again, just starting out, like how do you build this out? How do you start looking at what is out there? And then if you want to do more devices, I have a recommendation for the StarTech Industrial Hub that's got some jumpers in there that kind of helps you with power management. It's really awesome, that hub. It's done a lot of things for me. Just some examples of the hardware. This is the RTL SDR blog. SDR comes, you can get a kit with some antennas, an extension wire, a little pole, and that helps you get through the hardware side of it, right? 40 bucks, we can view the sky in 40 bucks. Because there are Windows tools that'll let you use SDR and see waterfalls and stuff like that. That's all very good. This is just a same hardware inside, a little bit different, and as well as just a different model and make, right? So again, another 40 bucks. You can throw it into an SBC. If the audience has been deep into Raspberry Pis, you probably have a bucket somewhere full of them. And if you don't, you probably have another bucket of something else, like a laptop that you can go, you know, grab from a thrift shop for 40 bucks and then throw Linux on it, and you can be off to the races. Other things that are in that spectrum, right? We talked about feeding the other ISM bands, but you have ADSB as well. So you can see the beacons from the planes. These planes have to, they don't have to, I guess, but they will beacon clear text, their call sign, their data, their telemetry, all be received with $40 device and antenna outside your window, mostly like clear line of sight. You need some sky. And I mentioned before, the BTLE and the Wi-Fi, right? That's where Kismet has its wheelhouse there. So my gripes, right? My gripes of being in the command line. You choose a Linux distro, you get your RTL SDR in there, and then you start running your terminal, and you just have a horrible time. The data's scrolling, it's swinging past you. You have to pipe it to a text file if you want to look at it later. It's just not, it's not exciting. It's not inclusive. It's not inducive to me to wanting to see that. I want to be able to capture it all and look at it. How do I go back? And how do I find that device? Was that device here? Was that device over there? Where did I go to get it? So yeah, just a horrible thing. I mentioned scrolling data. And data isn't always parsed properly. You can't really find it. And I want to save it. I want to look for it. I want to be able to watch it. And this gets into a little bit of like OPSEC and understanding what's around you and who's showing up and where are they going or where are they coming from or who they are or what they're driving. So an example of just this, I just call it chaos. It's just here, I'm going to go open up the RTL SD blog software, and I know it's an eye chart, but the slides will be up, so you'll be able to see them. But that's what it is, and it's just going to scroll. It's just going to scroll past, and you're just going to see all the things in that band. And how do you go back? How do you find the thing you're actually looking for? Where do you get the data from it? How do you parse it? You got to add all this extra stuff, all this extra lines or things on top of it in order to get a running access of that data. And so I think I've said data enough times. You know where I'm going with this. I want to be able to have that data. You want to be able to have that data depending upon what industry you're in or what you're doing. You may want to see what is happening around you. And, what happened there? So what if we were able to make it prettier? Now, this is censored because I was in an area that had a lot of things in it, and I didn't really want you guys to find out where I was, but I needed to be somewhere. So we have now, this is a 315 screenshot of Kismet Wireless. I'm really starting to feel like one of my slides is jumbled, but we're here already, so we're going to roll with it. This is everything it saw, okay? And I cropped the screenshot out, but there's pages and pages of things it found. There's pages. And now I can go back and I can click through what it had because it put it in a little database, SQLite or SQLite, depending on how you want to say that. And now you can go back. And that's the key is being able to store this data and replaying it and figuring out what you have around you at that moment of time. You can GPS tag it. I was smart enough to not do that this time. But there it is, right? You could just tag it and have that data. So what happens if we want to look at a TPMS sensor? I apologize. I think these slides got shifted. So we can see whatever it got parsed out. We'll work right to left. It's a little backwards. We've got the actual name of it. We've got a MAC address. It's decoding it as an RF sensor. We could even have the packet frequency distribution of what that sensor has been drifting around. We have total packets. So maybe that car parked for a while. Maybe it's in your driveway, but maybe it's parked for a little while. All right, so then we can get packet graphs. Okay, packets per second, packets per minute, packets per hour. Well, that's interesting. That thing is just chirping a lot. Again, I might want to just keep that in your mind. And then we get to see cool stuff, like there's an SNR, and there's the noise floor, and there's a temperature, and the actual tire pressure sensor, right? Because that's how your car does it. Your car is waiting for that number to drop and give you a little bit of an alert in the dashboard. So 433 megahertz is the same thing. You run it, and here's a bunch of sensors. This wasn't censored. It wasn't redacted. But these are those temperature sensors that you can buy, like $30. They usually report to like a weather station that has like a display on your counter or something like that. So now not only can you see what's at your house, but you can see what's at your neighbor's house, right? Because the frequencies are there, they're floating. But what about if we could store them all? What if I could get historical data out of that information, packet by packet now, to see trends, right? So I have a couple of these sensors. I throw them in the attic. I put one in the garage. I put one in the basement. And then the data just feeds. But I don't need a little weather station now. I got Kismet sitting in the background and listening to this data. So same thing here, right? We get our packet graphs. We get the actual name of what it is. We get a MAC address that it's using. We have a drift or frequency distribution. We have total packets. This is a good way to know if the battery dies in it, because sometimes those things don't tell you. So then maybe it's just stopped. It's totally dead. Good packet rates, packets for the last hour. It's interesting that we didn't have anything for the last minute and the last hour up here, but we had for the whole day, rather, last day. And then this one actually tells us about lightning strikes, storm distance, and a lightning sensor. Gives us the moisture and the thermometer, temperature. This is in the back of my server rack. You can tell which side the hot side is, I guess. Like a McDLT. Does anybody remember McDLT, hot and cold side? All right, I got one chuckle, good enough. So then we go back to ADSB, the flights. So this is very interesting because if you use FlightAware, the FlightAware, they'll accept customers to say, don't show people my information. Right? Now, there are other tools that you can go do that, but what if you got just something over your house and maybe you're in an area that somebody isn't feeding something? Well, now you'll get all that data, but this is ugly. What are you gonna do with this? Right? You're close, you kind of know, but maybe, what if I want it on a map? I might be from Long Island. So, so now you've got a full map of all the stuff overhead. And you get the full, and I don't know what this stands for, the ICAOID. And that's key because now you can take that anywhere else. You can take that to airframes.io. ADSB, right? You can go look that up and get raw data from people that haven't taken money from customers to hide their planes. I like to use this when the police fly over. I like to use this when the strange plane flies over that does a lot of circles. We recently had the Ryder Cup out on Long Island, and there was a plane that circled a lot, and we were all wondering, like, what is it doing? And is it the government? No, it was just audio-visual media team just doing circles all day. And but they paid FlightAware and some other people to not share their data, but nobody knew what this plane was doing. So we could fire up Kismet if we're in the area, if we're close enough, fire up Kismet, we run it, grab some ADSB packets, grab our data from the ICAO, and then start Googling, right? Or DuckDuckGo, whichever friend you have. And here's an example of that. I was able to find this plane that flew over, but it looked like FlightAware took the money, just an unknown owner in Brazil. We didn't have it close enough very long to get a full registration, but again, that ICAO, it's important. Look where it went. This is ADSB Exchange. They have a number of feeders, and like them or be frustrated with them, they do run a decent site for this. But it was weird because it did come over. It's tiny there, but it went straight over Long Island, and I did see it. That was odd to me. Seemed like an interesting flight path because the world is flat. Anyway, so now you have Bluetooth, right? Bluetooth we mostly know is randomized. Your phones are doing its best to randomize the MAC address that your phone is using over 24 hours or an unknown specified time. But there's a lot of devices that don't. Your car doesn't. I mentioned earlier, your Flipper Zero doesn't. So those are other things that can be used to identify people, places, things, yourself. That's what customers are doing. That's what people are doing out in the world. And so now you can too, at the very least, see what other people are seeing. And again, that's really my key here is I want you to go and step away and think about what you could go view where you are. Right? If you're in a dense location, you're like in a good apartment complex, you're gonna see so much stuff, it's gonna be so cool. If you are out in the middle of nowhere, you should see very little, and you should not see a whole lot of stuff. And maybe if you start to see a whole lot of stuff, you have some questions about what might be happening there. So it's just super, super awesome where you can take one device, you can tune it to Kismet on one frequency. You do have a Nyquist algorithm. I can't really articulate the answer to what that is, but it's a sampling rate, right? So if you were to only have one SDR and you turned it to 315 and you listened to it for 10 minutes and you tuned it down and you went to 915, you're obviously gonna miss what was in 315 that happened while you're on 915. So of course, it's always bigger, a little bit better in this type of stuff, but just from a perspective of what is around you, what's in your car, what's in your house, what's in the parking lot, what's happening if you have a store or a bar. I like to deploy a bunch of sensors in places that help me detect people in bars. So this is just a block diagram. I didn't have any pictures because I wasn't really allowed to share what I've built for other people, but this is it, right? This is a Raspberry with an SDR running Ubuntu, Kismet wireless, all in there, single data source, logs locally. I do recommend getting a little bit of a faster storage if you're gonna be in a very large area with a lot of data. But now you could just place this anywhere. You can remote to it. It'll, Wi-Fi back to the local network. Kismet Wireless has a browser, so you just browse to the IP address. You do log in and set up a password and stuff like that, but it's super important to be able to now, you have deployable recon devices. Blue team, red team, purple team, right? Those are great things to have. If you're red team, you might want to know what's there. If you're blue team, you might want to know if somebody showed up. If you're purple team, you want to know where everybody is. So you end up in that scenario of being able to have a defense, of a level of awareness of what you have. And that's really just, again, I'm just going to keep beating it. is that I just want everybody to know that for very cheaply, you can monitor what's around you like other people are monitoring what's around them. Other people. Agencies, government, whatever, local stores. If you think your Target and your other places are not doing this, I have a bridge that I like to sell people. I've sold it a few times. But it's a web server locally. You have complete remote via browser on the network. And there's a console access where you'll see, if you fire it up in console, Kismet will show you just streams of logs. But again, we're in that CLI. I don't want to be there. I want to be in pretty. But now we can get larger, right? If you set up a distributed system, you can now have sensors in 4 corners of your building, 4 corners of your property, maybe 2 down by the driveway and 2 down by the back gate. You could have a bunch sitting around here. This is not an original idea to me. I've learned this from others, and there's a thank you slide, right? But you too now can monitor things a little further away from home, at the edge of your house, right? We're in Pennsylvania, and people like to have large properties. I like the idea of having something distributed and being able to monitor what's around you. I moved a little bit fast here. If you want to try to capture everything, you can go crazy. This is a wall on the side of my server rack. This is now capturing everything. So there is a significant amount of capture happening here. And I could walk you through it. This is just to kind of show you that if you get into this rabbit hole, you might end up here. Because you're going to want to capture everything. And you're going to want to know what you missed. You want to know what maybe you might have missed, or maybe what you don't want to miss. But it's super important because this all will run off of a good, solid industrial USB hub to an Intel NUC i7, i9. And you're able to grab everything at once and pull it into that dashboard. And we've got a lot happening here. So let's go through it a little bit. This is a disco antenna, 30 feet in the attic on LMR 400 down into a mini circuits splitter. This is magic. This is magic that's happening here. This is allowing multiple SDRs to connect to one antenna. So the antenna just feeds stuff down the pipe, and all the SDRs are going to say, I'm going to look at this frequency. The other SDR is going to say, I'm going to look at this frequency. But they all shared one antenna, so I only had to run one wire, and I only had to have one antenna in the attic, which is good because my wife has been moving stuff around up there. She's wondering what all the wires are. So it's just excellent because this magic is happening here, and I'm not saying you have to do this. I'm just saying that you can find these cheap on eBay, used, and you can start to build out your own multi-device recon from a house. Maybe you live on a corner like I do. I didn't want to live on a corner, but I do. And so a lot of things happen on a corner. People like to stop on corners, and I don't know why, but you know what I want to do? I want to know when they do. I'd like to make sure that they're not littering, at the very least. If they could not throw their lunch out the side window as they drive away, I'd like that. There's a couple other things happening here. I do a bunch of other remote SDR stuff because you'll notice that there is a hack RF here. It's on its own dedicated line into that splitter. That's really dedicated to some other stuff where a separate server that I remote log into to access that data. And if we were to venture a little off topic, this is a Web 88 SDR. It's dedicated to a mag loop antenna, and it is just monitoring the PSK reporter. So it just listens to that HF frequency for oh boy, brain has blanked. But it's like the FT8, it's PSK, it's just listening, and it feeds to the reporter. So I can see people transmitting things in HF amateur bands from all over the world. Again, it's like magic. That's just a side project, but I just wanted to explain what's up there. I may have moved too fast. Like all things I try to present, I try to give you a logical diagram, a logical layout of it. The slides will be up on the site for JawnCon and in a dedicated GitHub link where I'll share some of the commands. But again, we've got your SDRs, 315, 433, 915, an ADSB, and a BTLE all in one set of hubs going to Kismet Wireless over here. This is doing some other stuff. We'll talk about that in a moment. But again, we have some more for some sneaky stuff. So maybe I just want to log in and hit a specific frequency from a remote device. So now I have logging and monitoring, and I have active recon, right? So SDR++ sits on a server, and it will sit here, and that goes to a different server here. And then I can remote to that from another computer on the network. If you're fancy, a VPN from anywhere, right, and come home. But we also do some dedicated ADSB. I did some comparisons between ADSB into Kismet, as well as FlightAware with a couple of different devices. Everything kind of really mapped out the same. So I won't say that you need dedicated ADSB, but if you're into flights, if you're into that information, the FlightAware tool is very cool. The other tools are very neat as well, and then you can document your stuff. I believe I moved too fast. So I've been joking about this for a while, like, do you have a moment to talk about our Lord and Savior, Kismet Wireless? I'm a salesman for it. I do believe that it is an incredibly powerful tool. It will save you a lot of time. You can export this data in a number of different ways. You can export your entire device list into a CSV. So now you have manageable data if you wanted to manipulate that somewhere else. I don't have a slide here for it, but I'm a big fan of GravWell. GravWell is like a competitor to the Splunk team. And again, you can now write query language against your data outside of Kismet if you wanted to. Kismet has a cool thing. You could filter up here. You can go to all devices. You can then filter against MAC address and break it down. This is just showing us everything. You know, we go back to the BTLE piece that's happening. This is a significant amount of BTLE data. So we have all this randomized MAC addresses. So hey, it's telling you it's randomized. You don't even have to, like, is it randomized? What is it? Maybe it's not. Nope. Kismet has identified out of the packets that it's received over BTLE that this is most likely a randomized manufacturer. And there's math behind that I don't understand or know. I'm not going to pretend I know it, but it's doing it for you. And that's really goes back to the heavy lift. The work is being done in Kismet Wireless. It's there. I don't see enough people talking about it. Maybe they are, and I'm just not friends with them. I'd like to be friends with you because it's so powerful. There's a number of different capture devices that I'm not even hitting. I installed a Zigbee like literally right before I showed up today, and I didn't see anything here right away, and I didn't see anything at home before I left, but it'll decode Zigbee. That's in there as well. So I wanted to come back to the slide where we had apologies. I think it was this one. So we get a manufacturer of the RF sensor here. I just kind of wanted to really make sure that we look at the 315 because I think the tire pressure monitoring sensor information is really critical to what you may see out there. I think it's something identifiable that enough people aren't aware of, and I hope that the teams here and anybody else that ever watched us understand how identifiable it is because of it being so unique. There's no duplicates. There just aren't. That's not the way it's been made, and nobody will know why, I guess. And then 433, right. I'm missing the slide with the gas meters, I guess is what I'm learning. My apologies. All right, so you can also see water meters. You can see gas meters. If they're reporting any data from consumption or delta or change, it's in the packet data. Kismet's decoding it for you, and it'll put you right in there. So I know when my propane tank at home gets full. Sometimes before I hear the dogs wake up when the guy slams the gate, right? So there's just so much data of yours out there. Out by me, the water van drives around. The guy from the water municipality drives around with 2 antennas on his car or truck, and that's how they read the meters to see the difference. And I'm seeing the difference as well. I know when the neighbors fill their pool, right? Like, it's weird. It's weird that this data is out there. And I think it's important that people know it's not just it's not just all the things you're thinking of, it's more. It's so much more. And because that slide is missing, let me hit acknowledgments, because I do really think that Dragon Kismet Wireless is such an incredible, powerful tool that if somebody like me can pick it up, who really has so little Linux experience, can read his docs and dig through them and set up a quick little box and then take that and build upon it and build upon it and build upon it. It's taken a few years before I've scaled it to chaos, or crazy, because the other stuff is chaos. But it just shows that you can see what's around you too, and that was really the point I was really going to hammer here. There is a Discord for Kismet Wireless. You go to kismetwireless.com. I can sell it. I'm wearing the shirt, right? So this way you can get in there. I'm always in there asking questions, sometimes looking a little silly, but it's just such an incredible group of people. I can't thank them enough out into the ether of the internet here, as much as I've even shaken their hands and given them hugs, because it's just a really powerful tool. And a lot of the work that I'm doing is really inspired. I just want to be really clear about Satan Claus. And there was a 2016 and a 2025 JawnCon presentation. The 2016 presentation is the one that kicked me off to go, how do I do that too? The 2025 presentation was like, oh my gosh, it's getting better. So I wanted to get bigger. And so I was able to just continue to expand upon the building of these tools, because I'm not going to get any taller. Nothing, you guys are quiet today, man. And I knew that I went fast, and I had a demo that's not working, so that we'll just drag just a tiny bit. The other set of Discord's channels that I would also recommend is the Radio Frequency Hacker Sanctuary. Zero Chaos is the individual that kind of manages and runs that group. Without Zero, I wouldn't know about some other tools that you'll see in the GitHub links. Use Supervisor D. Never heard of that before. So if you're a Linux person, you might know it, but Supervisor D really allows you to call commands in a nice, simple config. So that's how all of those devices get triggered here on that computer. Is each one has its own command line for a capture source. And as that capture source happens, Supervisor D controls that. And now you can stop and start from an easier command line, like maybe if you're driving and you want to pull over real quick and do an SSH into the back of the vehicle and make some changes, you can do it much easier without managing that. And it'll run in the background, so it's more of a service than it is a command line and seeing all the GUI stuff. And I really thank Zero Chaos for that. I wanted to go back to here, yeah. So that handles that. The Kismet docs are great at explaining where your configs belong and where they don't belong, and that's super important to maintain upgrades and compatibility and stuff like that. But I would say feel free to reach out to me in the Discord, in the DMs, anywhere you can find me. I do absolutely recommend, if you're interested in any of this stuff, get yourself a little SDR, get yourself a little what is it? single board computer like a Raspberry or NUC, or even a laptop out of a thrift store. I've seen people do some amazing things with this stuff, and I really feel that this will help you see what's around you. Maybe it'll give you a key to think about what you're carrying on you or where you're going and how you're parking, and just to be aware of what's around you, because I want to be knowing what other people are knowing. And this is as close as I think we can get without vans showing up and taking you away. Yes, and we would hope that we would know a strange van is coming. So the kit that's over there, I will get that working, and I will make sure that it's in the chill out room again. I just had a little trouble getting it operational, and I didn't want to waste any time. I wanted to talk to you folks who walked all the way over here and dealt with that elevator to come into here. So I do have time, because I know that I wasn't going to do the demo now. Are there any questions? Yes, sir.
With this kind of this type of monitoring equipment, is it feasible to receive, at least try to demodulate data signals from satellites? I know with the non-geosynchronous ones, you've got Doppler shift to worry about. But have you done that, and is how feasible?
So the question is, can we do satellites? And you can with SDR. There are a whole other set of tools for that. Kismet Wireless doesn't have anything today, but if you're a programmer, they're always accepting pull requests and code, right? But yes, software-defined radio is perfect for that. There are tools at the Suffolk County Radio Club for Amateur Radio Day. We did the GOES weather satellite. That's an SDR into a single board computer. It's reading the data from the satellite line by line and then generating that JPEG for that, what everybody calls like the big blue marble picture. But Kismet doesn't do that. SDRs do. And in fact, if you build out a system, you can have that SDR hanging off of one of your other machines that goes to a dish that's on the front lawn, if you're allowed to put a dish on the front lawn. I'm not allowed yet. Go ahead.
So you did this for a while. What was the one frequency that was like your aha? You saw something you didn't think you were going to find that you really fired it up and you're like, wow, that's really out there.
What frequency was the aha? I don't know if there was a single frequency that was an aha. What was more of an aha was, hey, when the leaves fall, I can see more gas meters down the block. I thought that was interesting. Like when propagation is happening that I don't really know everything about, every once in a while I see stuff from a block over. My disc cone is in the attic in the second floor. I don't have a picture of it, but I wanted to go to the diagram. So I live near a radio station. So these are things that you'll learn when you fire up SDR of what's around you, but there really wasn't any specific aha. It was more of like, okay, I know that exists. I've been watching people in the Discord. They've been pulling this data out. That exists, this exists. The Kismet docs, if you read the Kismet docs, you'll go, oh, there's a lot of stuff out there. But it was really more about how far I could go or how far I could see, where I was kind of like, why can I see 3 streets over? That's crazy to me. And that brings us back to like radio frequency. In the chill out room, I'll tell you what AM and FM I was told meant. It's like almost magic and something magic, right? That was just one of those moments like, this is kind of like crazy. But yeah, no, nothing specific, aha. I haven't seen anything that made me go, oh, I can see that. You're really reliant on the code from the RTLS SDR blog drivers or firmware that's in your Linux distro, or the drivers that come down, and then Kismet kind of wraps that up and shoves it into its database. There's another question. Yes, sir.
Does it do like any correlations? So can you say like, oh wow, whenever these tire pressure sensors here, so does this cell phone count? Like, it seems like for example, if cars have open Bluetooth and open tire pressure, right? You can correlate those. I was wondering if it does it.
The question was whether or not we can correlate any of this data to anything else we might know? I'm sure somebody can. Kismet Wireless is not going to do that for you. It's going to be some work that you're going to have to do. I know some folks have written plugins that'll do a little bit of trilateration, a little direction finding and stuff like that. I've never gotten them to work. And I never really went to go dig for that. But yeah, I mean, so the example that I think I can talk around is a sensor at a gate. And we would see the same tire pressure sensor monitors on the FedEx vehicle that we would also see the Bluetooth device that the FedEx driver drives, right? Like those are things that I have seen happen in a distributed property environment of, oh, we know that it's the regular FedEx guy. So going back to operational security and knowing what's around you, what happens when it's a different FedEx guy? What happens when it's the truck and you don't see the sensor? You don't see the same sensors and you don't even see the same Bluetooth device. Now what? Do we, well, I don't know if we keep them at the gate, but I think it's very interesting, right? It's a data point. And to your question, those are things I think that can help correlate some of that stuff, right? In the chill out room, I can have a very deep conversation about some of the correlation I've seen behind the scenes of other data. But from this perspective, yes, you could take those data points out. You can export them out as a JSON and a CSV file. And like I said, I import a lot of that stuff into GravWell and then do queries against the data. So I do that a lot with war driving. Go ahead. I'm sorry? I have not attempted to look at EasyPass. I have not been interested in that. I did drive with a bunch of sensors on my way here from Long Island. I'll take a look at the data and see what I captured, but I haven't really dug into reading EasyPass, right? That's a... Well, so the question goes back to now how do we correlate things together, to your point? So if EasyPass was running a sensor that was listening to your TPMS, then they would take your TPMS and your EasyPass and go, we now know that vehicle, and we may know if that vehicle changes. Go ahead.
So the data that you're collecting from the tire sensors, you have 4 unique MAC addresses. In Kismet, can you take those 4 IDs and then give it an alias so you know that?
So it's not necessarily an alias. We have functions within Kismet to write notes. So we can write notes up at the top. So this is currently empty, so it wouldn't make it an alias, but it would give you you can make a note that goes into the SQLite database. You can then go check for that later, and then you can start making some connections between what's in the driveway, what's parked outside, what's your neighbors when they come home, and what's the difference between like when the garbage truck drives by. Those sensors are always wild. And I know the data's incorrect from RTL SDR, and it's incorrect, I think, a little bit from Kismet, but it's always like 7,000 degrees Fahrenheit. Well, you know it's not that, but it's very interesting in terms of that data. But you would do that again outside of Kismet. Well, that's what I would do it anyway. But I would make notes. Now, if you have a series of MAC addresses, the filtering function is awesome. That's the wrong slide. Up here in the filter, you can filter for name, you can filter for MAC address, you can filter for a lot of different things. So if you did have a series of MAC addresses that you wanted, you can throw it into the filter and then consistently just look for those, right? I did this before upstairs. I was joking that there weren't enough flipper zeros here because I had thrown in the MAC address and just did a filter for just the Bluetooth for flipper zero. There's another question I thought. Yes, sir.
So the clock license plate readers are basically obsolete because we're driving around with 4 non-randomized MAC addresses on them.
Yeah, the question was, are the license plate readers and maybe the EasyPass a little bit obsolete? I don't think so from the business side perspective. I don't think EasyPass wants to try to figure out you going through their toll booth by TPMS sensors. They may want to go and look at TPMS sensors if you're driving through with no tag and unreadable plates, that might be a data point that they'd want to try to go find. Some of those pictures, though, have you seen them of the front of your car? They're pretty high res. I think they're going to read your registration on your car. They're going to read your sticker before they bother trying to do TPMS on you.
Speak to TPMS, go to the talk tomorrow, and we'll talk about why it's not a practical implementation. The broadcast range is too short. You basically got to have the audio antenna pointing directly at the tire while it's going by at 55 miles an hour. And you're in a very busy bandwidth where other things exist and you don't want to have a crosstalk. So you can't broadcast to the tires in that frequency.
So 11:30 tomorrow we're going to talk because I do love this game because I have a 40-foot setback from my house to the curb. I have an antenna about 60 feet from the curb, and I'm seeing every single TPMS sensor that comes out in the street 75 or 80 feet away. So yes, but no, right? Because going back to the diagram, right? I have a Lotus Systems low noise amplifier from 100 to 6 gigahertz pushing received information after the FM block into there. So I am shoving signal at these things. And I am at the behest, is that the wrong word? Should be, of the SDRs to figure that out, right, and get that data. But yeah, I can see TPMS sensors absolutely 3 houses away, which would be like 140 feet. And I don't know how.
20 meters is a good guess on what I get.
Perfect. 20 meters is a good guess. I love it. Anything else? Question all the way in the back. Speak up because I can't hear.
Hey, what's your data retention look like? How long do you collect data at your house, and how long do you store it? How much space would I be looking at if I wanted to?
What's your policy?
Who did GDPR just show up? The question was, what was the data retention? So, as an individual, you set your own policies, and you'll handle that yourself. So this data is small. The sensor data is small. I think I have 2 minutes. The sensor data is in the SQLite database. I want to say a 24-hour capture in a low traffic area, like my neighbors coming and going, and a couple delivery and FedEx and all that. I don't think it's over a gig. I don't think it's over a gig for that. So you're able to really scale that well when I go through like Manhattan. I want to say it's pretty significant. But when I'm in Manhattan, I'm doing a lot of other things. So that data is all combined in the SQLite database. Yes, sir.
I'm curious if you recall what the gain and the noise figure is for your LNA.
So,
You need that for the split.
yep. So what was the gain or the gain and the noise factor? So I honestly will tell you that I don't know. I include the part number there. I'm sure it's in some of the spec sheets. I'm normally a person of I'm pushing this stuff together, and if it's working, perfect, right? If it's not working, let me go ask somebody why. Yeah, no, you're absolutely correct, right? You're absolutely correct. The 20-something or 30 dB increase there is covering the dB loss across the splitter and pushing that signal out. And then we even get to pinch the gain back up in the SDRs, right? So if anything really starts to slip. But the magic is that it's still able to decode it, right? Like that's the gosh darn magic. I think any other questions? We'll ask one more time. Then we can close. Thank you, everybody, for sitting through this. I really appreciate it. Slides and everything. Thank you. Thank you very much. Slides and other stuff will be up in GitHub, and we will see you soon. I'll get that working, and we'll be in the chill out room later.